Hello and welcome to the section on equations, specifically how to write them, writing equations of lines. The first question that naturally comes to mind is why would we write equations? Well, we know that through the problems of the previous couple of sections that if you have an equation, you can get a lot of stuff out of it. You can stick in x and y's all day and get a ton of points. From that, you can graph it. In fact, if you write the equation in the right form, like this y equals mx plus b, that number right there is the slope. So we get slope from it. And right here, we can get very special points, intercepts. So this is the y-intercept. So this is why we called it the slope-intercept form of the line. The m and the b tell us the slope of all the y's and x's, the whole slope, and yeah, intercepts. And it tells us everything. Once you have the equation, you own the line. You have everything to do with it. So this whole section on writing equations of lines is to take various characteristics, maybe the graph, maybe an intercept, maybe some slope or points. Once you see a line, can you go backwards and write that equation of the line? Let's see how it works. If we were to start off with an equation, let's put this over here, equation like y equals 2/3 x plus 5, we know some things from it. We know how to pull the slope out of there. It's 2/3. We know a point on there really quick, specifically the y-intercept, 0, 5. I could look a little bit different. Y equals -4/7 x plus a 3. What's the slope? -4/7. That means it's headed down as it goes to the right, and we know that it goes through the point 0, 3. That's slick. So what if we know that the slope is 5/9 and it goes through a point, say 0, -13? Can we go backwards? Well, yes, if we know the slope is 5/9, we know the first part of the equation looked like y equals 5/9 x. And they gave us the y-intercept, so we know that that is the b, and it could be a -13. Oh, that's slick. Let's try another one. Slope is a -2 and has the y-intercept of 0, 4. Can we go backwards on that? Certainly we can. You're like, oh yeah, y equals -2x, and then it's plus that number. Inevitably, a smart aleck in the back of the classroom will say, hey, what if they give us a slope like 5/7 and it goes through the point, say, 2, 3? You'll notice this is not the intercept, so 3 will not show up right there. And the question is, how do you do it? Well, step number 1. Put in what you do know. Put in the slope. That is the first step that you'll do. So we'll write y equals 5/7 x. Look at that. We're really mostly there. The rest of it comes up when you're like, wait a second, but I don't know what the b is. I don't know what the y-intercept is. So we do this. Put a b right there for a minute. And step number 2 is they did give us a point that works. Now go way, way back to the very beginning. What does it mean for a point to be on that line? It means that when we stick 2 in for x and 3 in for y, it has to come out true. This is enough clue, enough information to find out what b is and then write it very nicely. So let's stick 2 in for x, so it is 5/7 times 2, and 3 goes in for y, 3 equals that, and there's our plus b. Now can we solve this equation? We can. This is going to be the second one. Put in the point. Yeah, put in the point, because that gives you enough clue to solve for b. In this case, you're going to solve it if you need to. Yeah. And then, well, let's do that. This is 3 equals 10/7 plus b. If we subtract 10/7 over here, this is common denominator, 21/7 minus 10/7 gives you 11/7. That's what b is, which means we really can go back here and say, wait a second, we know what that is now. It is 11/7. And so that's what we do, plus 11/7. And now we have an equation of the line given a slope and a point. Cool. I'm going to write that down as the third step that we need to do. 3 is, you know what, we need to write it so it looks nice. You need to write it so it looks like an equation of a line. The answer is not 11/7, that's only the y-intercept. If you just leave it out here or whatever, you might have get some points for work, but that's what it looks like. It should look like an equation where people can get slope and points. So write it nicely. There you go. Step number 1, 2, and 3. Let's try another one and see if we can get it. So if the slope is, let's say, 4/3 and it goes through the point 5, 1, let's try that guy. First of all, put in the slope, so we know it's y equals 4/3 x plus b. We don't know what the b is, so let's change it and do it in a little bit different color here, plus b. Now we stick in the point, put in that point. So 5 goes in for x, so it should be 4/3 times 5 equals 1. There's a plus b over there. And now solve for b. This is 20/3, and this is 3/3. So 3/3 minus 20/3, b is going to be a negative 17/3. And then write it nicely. Let's change back to the color, and we get y equals 4/3 x minus 17/3. And now we have an equation of the line. Isn't that slick? A lot of people have done this, and you can do this over and over and over, and you can solve it all this way. But there is a nifty way that somebody has said, hey, there's a way we can do this all at once. So we're going to pause and take a little break and show you this snappy little way of doing things. They started off by saying, wait, we know that m is y2 minus y1 over x2 minus x1. This is the same as saying, so change in y over the change in x, rise over run. If we times both sides of this equation by the run, it looks like this. x2 minus x1 equals y2 minus y1. Now the common thing about all lines is that m is always constant. If you take any 2 points, x1, y1 and x2, y2, along that entire line, you get the exact same number m. Well, if you start with m and say, you know what, let's, instead of doing it between 2 points we know, let's take 1 point that we absolutely know, and the other point, what if we didn't know it? And just call it x and y, like a generic x and y. And they write it like this. It's kind of a snappy little thing to do. They write this side first. They write y minus y1 equals m times x minus x1. So this x and this y are like generic x and y points way out yonder and describe everything that has that slope through a particular point x1, y1. You're like, well, how does that help us? Well, let me show you. This is kind of cool. Putting in the slope, putting in the point, you can actually do this all in one step. Let's take this, this one right here, and let's do it using this formula right here. I'm going to use this orange and write it out right here. Y minus y1, which is 3, equals 5/7 x minus 2. And you're like, what? Yeah, we put in the slope and the point at the same time. Now we just have to write it nicely. So we're going to jump the 5/7 in, and we get y minus 3 equals 5/7 x minus 10/7. Then we add 3 over here. So that's adding 21/7. And we get y equals 5/7 x plus 21/7 minus 10/7 is plus 11/7. Oh, what now? Did you see that come out of there? That's amazing. Yeah, this right here, I'm going to write it down a little bit lower, and so everybody can see it. This formula, y minus y1 equals m x minus x1, is kind of a shortcut. We call this the no think all in one. Okay, because you're able to do these two things in one step. It's the no think. You don't have to think about put this guy in for x and y and then rewrite it and whatever. No think, all in one. You stick in. Notice what it has here. Let's highlight this with a nice pretty color here. It has the slope, and it has the y1, x1 are a point. So the official name for this form of a line is the point-slope form. All right, let's do it one more time with this guy right here. So we're going to take this guy right here, and we're going to do it, and we're going to come up with this answer in no think, all in one step. Y minus the y value, 1, equals m x minus the x value. Just like that. Y minus, so y1, x1, y1 is actually a point that you know the numbers of. X and y are what will end up in the equation as the generic x and y of the equation. All right, now let's just solve and write it nicely. So we get y minus 1 equals 4/3 x minus 4/3 times 5 is 20/3. And then when we add 1, that's adding 3/3 over there. So we get 4/3 x minus 20/3 plus 3/3 is minus 17/3. Is that not the slickest way you've ever seen to work with that? Yeah, it's great. All right, so here are a couple of problems to give a try to. We won't go to the board yet. I need to show you one more thing, but let's give these guys a try. We're going to use this no think all-in-one option, the point slope form of equation. So we're going to have y minus y1, which is 3, equals m, which is negative 5/8, x minus 5. You see that guy right there? Holy cow. We put in the slope, negative 5/8. We put in the point, step 1 and 2, all at the same time. There's x1 and y1. And then we write it nicely. So simplify this thing. So that becomes y minus 3 equals negative 5/8 x plus 25/8. And now we're going to add 3 to this side to make it look nice in y equals mx plus b form. So we add 3, and that's adding 24/8. So it's going to be y equals a negative 5/8 x, and add 24/8 over there, and that's plus 49/8. Perfect. Let's try another one just to make sure we got it. Put in the slope, 2/9 is going to be x minus a minus 4. And over here we get y minus 7. Y minus y1 equals m times x minus x1. So that's a plus sign in there. Now let's write it nice, and we get y minus 7 equals 2/9 x plus 8/9. Excellent. Now add 7 over. So you get, let's put this plus 7 over here, scribble that guy out, and we're going to have y equals 2/9 x plus, let me see, that's 63/9 plus 8/9, that's plus 71/9. Whoo, look at that. We got it. That thing is pretty slick, this point slope form. There is one thing that we have kind of overlooked a little bit, and that is standard form. Some of you guys may appreciate this. This will not be required, but it is kind of handy. If you remember, standard form looks like this. And where you could pull out the slope, this was the kind of the little pattern. And so you can, if you'd like to, if you want to turn this into standard form, you've got to times everything through by 8. Negative 5x plus 49. And that's the cool thing about standard form, is that there are no fractions. And then add 5x over here, and you get 5x plus 8y equals 49. And you'll notice, hey, look, negative 5/8 was indeed the slope. There's also a way you can do standard form from the get-go using these exact same 3 rules. And I'll show you what I mean. One way to get to standard form is just to multiply through by the common denominator, and then pull the x's over here and make sure it's positive. You may have to divide by a -1. Or you can say, wait a second, if the slope was 2/9, then that had to have come from a 2x minus 9y. Do you see how this would be putting in the slope that 2 over -9, and the opposite of it will give you positive 2/9? If you don't see that, don't worry about standard form. You could just times through by 9 and be okay. But if you can see that this is that pattern, if there's a minus sign in here, it's a positive slope. If it's a positive sign, it's a minus slope. So 2x minus 9y, put in the slope. Now put in the point of -4/7. -4/7, and you get -8 minus 63 is a -71, and then you write it nicely like that. That would be the same thing as timesing through by 9. 2x plus 71. Subtract the 2x over here, plus 9y equals a 71, and then times through by a -1, so it looks nice with a leading coefficient that's positive. Again, we'll work out problems that have this, but this is not necessary. If you are able to do the point slope form, that is sufficient, but for some of you, this slick little trick of making it with no fractions whatsoever is going to be pretty cool. All right, let's give you some to try on your own. To the boards! Go ahead and give these a try and then press pause and see how well you did. When you're ready to keep going, unpause the video. All right, the ones we're going to be using is y minus y1 equals m, x minus x1. And for those of you that are overachievers, down at the bottom, we're going to use the standard form, ax plus by equals c. And remember, the formula there is slope is going to be the opposite of a over b. So if that's helpful to you, we'll do that down at the bottom, kind of as a bonus. But let's go through them one at a time. This is going to be y minus y1, which is 4, equals m, which is 5/8, x minus 0. Now notice when we simplify this guy, y minus 4 equals 5/8 x minus 0. When we add 4 over there, you're like, wait a second. We had the y-intercept the whole time. Yeah, we could have just stuck the slope in there for y equals mx plus b and then had 5/8 x, and that was the y-intercept. So that was kind of slick. Bonus question down here, in standard form, you could times everything by 8 and then pull the x and y over, or using this thing, you'd have a 5x minus an 8y. Let's get the color there. So 5x minus the 8y. Now again, it's this opposite sign, if you've forgotten that shortcut. And then you stick in 0 there and 4 there. 5 times 0 is 0, minus 8 times 4 is a -32. Cool. All right, back to number 2. The slope is -4/3. If we stick in the slope, -4/3 right there for m, x minus x1 goes there and equals y minus y1, which is a -2. So we get y plus 2 equals, jump that in, and we get -4/3 x plus 28/3. Excellent. Now we just have to write it nicely. Subtract 2 from both sides and we get y equals -4/3 x. Subtracting 2 is subtracting common denominator 6/3, which is now 22/3. Right on. Good deal. And number 3. 2, -4, and 5, 4. It goes through those 2 points, but we don't have a slope. Wait a second, I know how to get the slope. That's right, you get the slope by -4 minus 4, y minus y, over x minus x, 2 minus 5. So we get -8 over -3. The slope is positive 8/3. Okay, so if we stick it in, we get y minus y1. Oh shoot, are we going to use that point or that point? Well, let's use this one and see what happens. Y minus y1 equals 8/3 x minus x1. Okay, so y plus 4 equals, jump that guy in, and we get 8/3 x minus 16/3. And now we subtract 4 from both sides. So that's subtracting 4 is subtracting 12/3 if we have a common denominator. So that's going to be minus a 28/3. Little point that is I love to make is, what if we would have used the other point? Y minus this y equals 8/3 x minus this x. If there's any justice in the world, we better end up with the same equation. Let's try that. So we get y minus 4 equals 8/3 x minus 40/3. And now we add 4 to both sides. So that's y equals 8/3 x negative 40/3 plus 4. Common denominator is 3, so that's plus 12 thirds. Negative 40 plus 12 thirds is negative 28 thirds. Wow, look at that. Isn't that amazing? And for those of you that like seeing above and beyond, we're going to do the standard form down here, and you're going to see a very similar thing happen. So if we were to do standard form, negative a over b, so this has to be 4x plus 3y to have that slope, and then we stick in 7 for x, stick in 2 for y, and we get 28 plus 6 is 30. 28 plus 6 is 34. Oh, that's a negative. Just kidding. Let's back up there just a bit. That's a negative 2 we're sticking in there. So it's 28 minus 6 is a 22. And what's cute is if you were able to solve for y here, subtract 4x, divide by 3, you'll get this exact, those are the exact same equation. Let's do it over here. The slope is 8 thirds. It would have to be in an 8x minus a 3y to get a positive 8 thirds slope. And let's stick in the point 2, negative 4. 8 times 2 is 16, minus 3 times the negative 4, that's plus 12, is 28, using no fractions. Now what if we did it with the other point, just like we did up here? 8x minus 3y equals, and we stuck in 5, 4. 8 times 5 is 40, minus 12 is 28. And if you take and solve this for y, subtract 8x over, divide by a negative 3, you will get the exact same points. Awesome. Great. Let's move on to the next thing.
Now that we've learned how to write equations of lines, we're going to use that information to predict, where we go from known data, just a little bit about a line, and we're going to ask questions about stuff that we don't yet know. And how do we get there? Like if we have something, slope is 1/2, and it goes through the point 4, 1, what happens? What will y equal if x is like 22? How do we move from this known little bitty data about a line to unknown and predict in the future what will happen when x is a much larger number? Before we do that, we have a talk by Elder N.L. Anderson that talks about what you do when you only know a little bit and you wish you knew a whole bunch more. Listen to this.
While there are many experiences like the one we are having today, full of spiritual power and confirmation, there are also days when we feel inadequate and unprepared, when doubt and confusion enter our spirits, when we have difficulty finding our spiritual footing. Part of the victory as disciples of Christ is what we do when these feelings come. Nearly 40 years ago, as I contemplated the challenge of a mission, I felt very inadequate and unprepared. I remember praying, "Heavenly Father, how can I serve a mission when I know so little?" I believed in the church, but I felt my spiritual knowledge was very limited. As I prayed, the feeling came, "You don't know everything, but you know enough." That reassurance gave me the courage to take the next step into the mission field. Our spiritual journey is the process of a lifetime. We do not know everything in the beginning or even along the way. Our conversion comes step by step, line upon line. We first build a foundation of faith in the Lord Jesus Christ. We treasure the principles and ordinances of repentance, baptism, and receiving the Holy Ghost. We include a continuing commitment to prayer, a willingness to be obedient, and an ongoing witness of the Book of Mormon. The Book of Mormon is powerful spiritual nourishment. We then remain steady and patient as we progress through mortality. At time, the Lord's answer will be, "You don't know everything, but you know enough. Enough to keep the commandments and to do what is right." Remember Nephi's words? "I know that he loveth his children, nevertheless I do not know the meaning of all things." I once visited a mission in Southern Europe. I arrived on the day a new missionary was preparing to return home at his own insistence. He had his ticket to leave the very next day. We sat together in the mission president's home. The missionary told me about his challenging childhood, of learning disorders, of moving from one family to another. He spoke sincerely of his inability to learn a new language. Then he added, "Brother Anderson, I don't even know if God loves me." As he said those words, I felt a sure and forceful feeling come into my spirit. He does know I love him. He knows it. I let him continue for a few more minutes, and then I said, "Elder, I'm sympathetic to much of what you've said, but I must correct you on one thing. You do know God loves you. You know he does." As I said those words to him, the same Spirit that had spoken to me spoke to him. He bowed his head and began to cry. "Brother Anderson," he said, "I do know God loves me. I do know it." He didn't know everything, but he knew enough. He knew God loved him. That priceless piece of spiritual knowledge was sufficient for his doubt to be replaced with faith. He found the strength to stay on his mission. Brothers and sisters, we each have moments of spiritual power, moments of inspiration and revelation. We must sink them deep into the chambers of our soul. As we do, we prepare our spiritual home storage for moments of personal difficulty. Jesus said, "Settle this in your hearts, that you will do the things which I shall teach and command you."
Oh, I love that. You know enough. Powerful lesson for all of us to get those foundational things that we do know deep into our hearts so that we are prepared against times of trial. In math, there's a very similar thing, probably not as impactful as a lesson by Elder Anderson, but it has the same concept of moving. We do know something. Do we know enough to go to the unknown? And yes, we do. We know how to write an equation like this. You remember y equals mx plus b. We can use this to write an equation of a line. We know that 1/2 goes in here, and but we don't have the b, but we can find it if we write y equals 1/2 x plus b, and now know that this guy's our x and that guy's our y. We can stick those in. Y equals 1/2 x, which is 4, plus b. And that becomes 1 equals 2 plus b. Subtract 2, and b is -1. That's our y-intercept. So we now have the equation that we can write to use for the rest of whatever we don't know. Y equals, here's our slope, 1/2 x, and here's our b, -1. This gives us the equation and the ability to predict. Now we come over to the unknown portion, and it says, what is y when x is 22? Well, yeah, we can stick a 22 right there. Y equals 1/2 22 minus 1. Y equals 11 minus 1 equals a 10. That means the point 22, 10 will work. And notice what we've done right now. We have taken just a little bit of information, 1, 2, 3, 4, 1, something right there with a slope of up 1 over 2. And you'll notice it goes something like this. And we said, what happens when x is way out here at like 22? How high up are we going to be? And we were able to answer that question. So here's one for you to try. Go ahead and write down this information that you know, and from that, write an equation of a line and predict what would happen when x is 21. What value of y will we have? And go ahead and pause the video, and then press unpause, and we'll work through it together.
Okay, hope we are able to do it. Remember, we're shooting for something where it's y equals mx plus b, and we need to stick stuff in. Well, look at that, 2/3. We know we'll go right in there, so we know it's going to be y equals 2/3 times x, but this point is not the y-intercept, so we actually have to use a little bit of sleuthing to find out b. So we take this guy as x and that guy as y, stick this in for x, so we get 2/3 times 9. Watch out, don't stick that over in for y just because it comes on the left. 2/3 times 9 plus b has to equal 1. We get 1 equals 2/3. No, what's 2/3 times 9? Put it in your calculator or simplify. That'll be 6 plus b. Solve for b, and we get b equals a -5. Good. So what does that tell us about our equation? The equation is now y equals, we know m is 2/3 x minus 5. That's the y-intercept. That's great. With all of this stuff, we produced an equation, and now, oh yes, once we have an equation, we know everything. We took what we knew, which was not very much, but now we know enough because we can do anything and take this 21, stick it right in here, and we get y equals 2/3 of 21 minus 5. 2/3 times 21, that is, let me see, 21 divided by 3 is 7, times 2 is 14, minus 5, y equals 9. So this means it's the point 21, 9. I'll put that right up there. 21, 9. There we go. How'd you do? To the boards!
Okay, so here we have one final question for you to work on. With prediction, here we have this kid named Ralph. Ralph at age 2 weighed 45 pounds. At age 8 weighed 87 pounds. I did a little graph of what was going on here. Here's age 2 at 45 pounds. Here's a little squiggle. Sometimes they do that because obviously if this is out 2, they had to skip a few to get up to 45. So they kind of zoomed in on that. Okay, so 45, and then at age 8, he was 87 pounds. So this is kind of a coordinate like that. It says if he grows at the same rate, meaning a linear growth here, which, you know, kids go through growth spurts and then they stop for a little while, saying when you're out here at 18, make a prediction as to what his weight is going to be. All right, so go ahead and pause the video. Note that you'll have to use this 245 as one point and 887 as another point to get the slope to produce that line. But go ahead and pause the video, work on this, see if you can predict his weight at age 18, and then go ahead and unpause the video and let's work through it together. Okay, how'd you do? Let's give it a try. First of all, we're going to be writing an equation that is y equals mx plus b. We need that equation, and in order to do that, we need the m. So we actually have to find the m on this one, which is y2 minus y1, which is a 45, over x2, which is an 8, minus x1, which is a 2. So that is 42 over 6 is 7. Oh, good. We have m now. So now let's write the equation of the line here. We have m, and we know that. So now we've got to find what b is to write this equation. Well, we know we've got an x and a y here we can stick in. Let's go ahead and do that. Let's take this x and this y and go ahead and find out what b is. So y is 45 equals m times x, which is 2, plus b. And now we're going to find b. That's 45 equals 14 plus b. Minus 14, we get b equals 31. Yay! So we have b equals 31 and m equals 7. We know what this equation is now. This is y equals 7x plus 31. And that gives us all of the information we want. Now, some of you may ask, just while you're doing this, hey, wait, I used 8 and 87. Is that okay to do? Well, let's write it down here and let's see what happens. You have 87 equals 7 times 8 plus b. And that's 87 equals 56 plus b. Subtract 56 and you get b equals 31. Yeah, they have to come out the exact same because these 2 points right here are both on this line, so they better come out with the same intercept. All right, Now that we have this information, let's predict it. Age 18. So when x is 18, we're going to stick 18 right there. So y equals 7 times 18 plus 31. Y equals, let me see, that's 126 plus 31. Y is 157. We get that his weight will be around 157 pounds when he's age 18. Probably still gangly and hasn't filled out totally yet. Okay, this is great. You now know how to use this small bit of information. You know enough to write the equation and make a prediction into the unknown.
The last thing we can possibly throw at you with lines is this concept of lines that are parallel or perpendicular. This comes from geometry where two lines never touch and where they cross at exactly 90 degrees. Let's look at equations of lines and see how they relate. This is a nice easy one to see. If I have something like 2/7 x plus 5 and y equals 2/7 x minus 3. Okay, graphing the purple one. Let's get a little grid here and let's see what's going on with these guys. If we graph the purple one, it says y equals 2/7 x plus 5. So right up here at plus 5 and then 1, 2, 1, 2, 3, 4, 5, 6, 7. Right there. Oops, that's what I meant. Okay, so that's good. And then the orange line is down here at -3 and it goes up 2 and then 1, 2, 3, 4, 5, 6, 7. And it looks like that. Now, if you look at these two and you ask the question, are these two ever going to touch? Well, no, they were exactly 8 apart here from -3 to 5 at the intercept. And by the time you come up here, it's exactly up 2 over 7 on both lines. Up 2 up here over 7. And so they will always stay exactly that far apart. The easy connection with parallel, you can see it on the graph and you can see it immediately, is that two things have the exact same slope. So that's what happens with parallel. They have the same numerical value for slope. Okay, good. Let's try perpendicular. And this way we're going to go a little bit backwards. Let's take this line right now, something with a slope of 2/7. So let's graph this guy. Slope of 2/7 here. And perpendicular. Think about what that would mean. So we did this and it has a slope of 2/7. So what would happen if you took and cranked this line? Let's hold it fixed somewhere, like, I don't know, right about here, and you pushed this guy that way and you took this part of the line and you tugged him that way until he came right down through there at exactly 90 degrees. Well, what would this triangle look like? That guy would come up about right here and it would look like this. That 2 would be here and that 7 would be here. What used to be the rise is now the run. And what used to be the run is now the rise, except for instead of going up, it's going down. The slope of this guy is a -7/2. Yeah, so that's how we get perpendicular. If you have a slope of 2/7, it's opposite, so negative, because it was going up and now it's going down. And it has to flip the rise and the run exactly opposite of each other. So we call it a negative reciprocal. So let's do another example really quick. If you had something like y equals 3/8 x plus 4, well, that's up here starting at 4, and then you go up 3 over 8, and it would look just like that. Every other parallel line would have to have a slope, oh, didn't draw it very parallel, that's what I meant, would have to have a slope of 3/8. However, the perpendicular slope, on the other hand, would come down this way. And there are billions of lines with that slope, and that slope would be a -8/3. So a negative reciprocal. Let's see it listed out in a couple of examples. So how does all this look in problems that you're going to see? Well, Let's look at it and see how it works. So parallel and perpendicular, first of all, if you have a slope such as 3/8, you need to be able to tell from that what its parallel slope is, the same thing, and what its perpendicular slope is, negative reciprocal, so 8/3. That's it. Not a lot to know except that is the relationship. Same here, and negative reciprocal. 1 over x is how they'll represent that on a calculator. So if this is a -2, anything parallel to that has the same slope, -2, and perpendicular slope would be positive 1 over 2. If you have a slope such as 7/2, parallel would be 7/2. Exactly the same. And then the perpendicular would be a -2/7. So how does that help in doing equations of lines? When it says write the equation of a line that is parallel to this line, 5x minus 3y equals 19, you've got to think, well, in order to write the equation, what do we need? We need the slope of the line. Well, we know the slope of this line. Slope is 5/3. We know how to do that one. So the slope that we want is 5/3 because it's parallel. That's what we want. So we've got to have that exact same slope, but we now go through the point 2, 1. So this is the problem that we need to do, and we extract that information from knowing the relationship of parallel lines with their slopes. So this 19, useless. We don't need it. We just needed the slope. So we can now do either the y equals mx plus b way, 5/3 x, plus b. We don't know what b is, but we can stick 2 in for x and 1 in for y. 1 equals 5/3 times 2 is 10/3 plus b. And then subtract 10/3 from both sides. 3/3 minus 10/3 is negative 7/3 equals b. So we get y equals 5/3 x, and we now know b is minus 7/3. There you have it. Now we could have done it putting it in standard form, the slope 5x minus 5x minus 3y. So that's the opposite of 5/3, the 5, and then the opposite of the 3. And then we stick a 2 here and a 1 there, and what does it come out to be? 10 minus 3 is 7. So 5x minus 3y equals 7. And the third way of doing it was y minus y1 equals m x minus x1, and then simplify it. So jump that through and we get y minus 1 equals 5/3 x minus 10/3, and then add 1 over, which is 3/3 over to there, and we get y equals 5/3 x minus 7/3. So either way, we'll end up with the exact same line here. They are in the same form or in standard form. Any of those would be correct. Okay, let's look at the final one down here. Write the equation of the perpendicular bisector of the segment between -3, 7 and 5, 1. What? Write the equation of the perpendicular, so we're going to be using perpendicular bisector of the segment. Let's draw this out and see what this actually looks like. So we have -3, 7 is up here, -3, 7, okay, and 5, 1. Right here, 5, 1. And we don't want the equation that goes through these 2 points. We want the perpendicular bisector of the segment. So if the segment goes between them, we want the thing that comes down here and chops that guy right in half. Perpendicular, 90 degrees, bisector. So how are we going to do that? Well, we don't have a lot of information except we do have these 2 points where we can get the slope of this guy right here. So the slope of that segment is 7 minus 1, y minus y, over -3 minus 5. That is 6 over -8, -3/4. Okay, does that make sense? It's going down, negative, yes, and it's kind of gradual, not bad. So the slope, we don't want this slope, we want perpendicular to that, so this slope is a positive 4/3. That's the slope we want. Slope is 4/3. Now we need to know what this point is because this doesn't go through that point or that point, so we can't use those guys. We need to use the one right in the middle. So how do we find in the middle? Well, -3 plus 5 is 2, divided by 2 is 1. We're just averaging. The second one, 7 plus 1 divided by 2 is 4. There we go. So that is the midpoint. All we did was average the -3 and the 5, and then we averaged the 7 and the 1. That's finding the bisector, the midpoint of that. All right, now we can do this. So in standard form, we would go 4x minus, remember opposite sign, 3y equals, and then stick 1 in here and 4 in there and see what happens. 4 minus 12 is a -8. So that's standard form. And let's do point slope. We could do y equals mx plus b as well, but let's do y minus y1 equals m x minus x1 right there. And then jump that in. We get y minus 4 equals 4/3 x minus 4/3, and then add 4 to both sides. Y equals 4/3 x minus 4/3 plus 12/3 would give us a positive 8/3. And you'll notice that is the same thing that you would get if you took this and solved for y. Subtracted 4x from both sides and then divided by a -3. Okay, let's give you an opportunity to do some problems. That's right. To the boards! It is time to go to the boards. Give these a try, pause the video, and then unpause it after you've had a chance to do them, and let's see if you got the right answers. Welcome back. Number 1, slope. Here are some slopes, parallel and perpendicular to that. Well, the parallel, that's easy. I'm going to do them all at the same time. Yeah, the parallel slopes are exactly the same as the originals. Parallel means the same steepness. Perpendicular, however, negative reciprocal. Negative reciprocal, which turned it to a positive. Ooh, this guy is horizontal, so the negative reciprocal, 1/0, dividing by 0 is undefined. So this is a vertical line. So vertical and horizontal are perpendicular. Yeah, that makes sense. And then this one would be a -5. Good. Number 2, write the equation of the line that is parallel to this. So what's this slope? This slope is m equals 3, and we want it parallel to it, so that's the slope we want, m equals 3. And it goes through the point -2, 1. Oh, I'm glad they just gave us that point. So you have 3 ways to do this. You can do standard form, which is 3x minus y. Remember, opposite sign of 3/1 equals, stick -2 in there and stick 1 in there, and we get -6 minus 1 is a -7. You could do y equals mx plus b, or point slope form, which is y minus 1 equals 3 times x minus a -2. So we get y minus 1 equals 3x plus 6, and then add 1 over, and y equals 3x plus a 7. So you could have written as y equals 3x plus b and then stuck in those points to find b as 7. But it will look like that or like that one. Either way. All right. Write an equation of the line that is perpendicular this time to this, y equals 3x plus 87.4, and goes through that point. Well, what's this slope? Slope is 3. We don't want that slope. We want the perpendicular slope. So the one we actually want is slope is -1/3. Let's do it y equals mx plus b route this time. We get y equals -1/3 x plus b. Stick a 1 in there and a 1 in there, and we get 1 equals -1/3 times 1 plus b. Add 1/3 to both sides, and we get 4/3. So that is y equals -1/3 x plus 4/3. If we did it standard form, it would look like 1x plus 3y equals, and we stick a 1 in here and a 1 in there. 1 plus 3 is 4. So standard form and slope-intercept form. Good. Number 4, write the equation of a line that is the perpendicular bisector. So we're not going to go through either one of these points, and we won't have this slope. So I always kind of need to draw these out to make sure I know what's going on. -1, 2, and 5, 10. Ooh, that looks like a very large positive slope. And so there's the segment. So we want the equation of the line that cuts it exactly in half. What a great problem. We've got to find the slope, first of all. So the slope of these two, between these 2 points, slope is 10 minus 2 over 5 minus a minus 1. So that's 8 over 6. So this is a positive 4/3 slope. We don't want that slope. We want this one right here. So we want the perpendicular to that, which is, slope is a negative 3/4. Now, what point does it go through? It doesn't go through negative 1, 2, and it doesn't go through 5, 10. It goes through the middle of them. So let's average them. Negative 1 plus 5 is 4, divided by 2 is 2. And 2 plus 10 is 12, divided by 2 is 6. So this point is 1, 2, 1, 2, 3, 4, 5, 6. Right there, 2, 6. All right, can we do it? Yeah, let's do standard form, 3x plus, opposite of that guy, 4y equals, stick a 2 there and a 6 there. We get 6 plus 24 is 30. All right, let's do point slope form. Y minus 6 equals m, negative 3/4, times x minus 2. Again, y minus y equals m, x minus x1, and that works. Okay, y equals, let me see, that jumps in, negative 3/4 x plus negative 3/4 times that is positive 6/4. Is that right? And then adding 6. So add this 6 onto the other side. So let's see what that does. Y equals negative 3/4 x. 6/4 plus 24/4 is 30/4, which simplifies down to 15/2. And there you have it. Good. Now let's move on and look at some inequalities.